All right, what up, fam? Let's get going with Mod 17 quiz review. These ones should all be nice and simple. A fraction of the circumference, so the portion of her circumference we call the arc length of a circle. All the points in the plane that are equidistant to a given point. That is our definition of a circle. I used a fancier word instead of all points. I used the word the locus of all points, because that's kind of like the more correct way of saying it, but anyways, a segment whose endpoints are the center and a point. So from the center to the edge, we call that a radius. A segment that intersects the center and the circle at its endpoints, that is a diameter going all the way across. The distance around a circle is our circumference. And the last one, a fraction of the area of a circle, that sector area. Boom. All right. All the rest of these, they give you the formula in the question. I don't think these can even get easier than they already are. Let's just do them. So circumference here, 2 pi r. There's our radius. Point to it. There's r right there. So our circumference is 2 times pi times that value 4, and we're going to write our final answer as 8 pi. So really we just did 2 times 4. Feel free to plug it into your calculator, but if you do, leave the pi as a 1. Otherwise, you're going to get this decimal number that we don't really want for the purposes of the ACT, which is going to have your answers in terms of pi. What is this area? A is equal to pi r squared. So area is pi multiplied by 4 squared, and 4 times 4 is 16. Boom, boom, boom. I'm not going to be too much of a stickler on the actual test about the units. I just don't care about it on these 1-point tests, but it's a good habit to get into for your physics classes, for your AP calculus eventually. If you decide to take it, you're going to need those units for questions that require it. So you might as well practice using it, that the lengths have regular centimeters, and areas are going to be centimeters squared, and volumes will be centimeters cubed or meters or inches or whatever. All right, given the circumference is 20, and it gives you that formula again. What is the radius? This is our basic filling in. It says that this right here is 20 pi. So 20 pi is equal to 2 pi r. It is a great rule just to get in habit of. If you see the same thing on both sides of the equations, unless it's the variable you're solving for, they just cancel out right away. So feel free to like fill those in with red or something if you're trying to feel fancy about it. But like those pi's just boom, gone. Not even there anymore. Then after this, we're going to divide both sides by 2. Dividing both sides by 2, you're going to get 10 is equal to the radius. And it does say centimeters, right? So maybe I should rewrite this. R is equal to 10 centimeters. Use those units I just told you about. Beautiful. Let's move on to the next one. All right, given the area of a circle is 64 pi, what is its radius? So same concept as that last question, except this time you have 64 there. Yet again, the pi's are just going to go away, disappear, fade into the oblivion. And then we are going to take the square root of both sides. So just to show the extra work here, that's what I'm going to do. I'm going to take the square root of that, and therefore 8 centimeters is equal to r. Very nice. Number 11 kind of combines the idea of numbers 9 and 10 into 1, where you have to find something and plug it into the next equation. So let's just go ahead and try it. Not too bad here. Given the area is this 36 pi, so 36 pi is equal to pi r squared. Therefore, 36 is equal to r squared. I'm skipping showing the square root. It's the same idea here, though. So 6 is equal to r. And then after that, we're going to plug it in to this equation. C is equal to 2 times pi times our value 6 that we just got. C is equal to 12 pi. Bada bing, bada boom. We done. Move on to the next side. Here we go. The back side. Here we go. So, what is the arc length? In my class, I didn't use m. I used theta. And I didn't use L. I used S. Those are the more common ones nowadays. The L and the M were kind of more 1990s. So yeah, that's all I'm going to say. All right. So we got our S and our M there. Now they're theta and whatnot. What is this arc length? All you have to do is throw in those formulas. So we have S is equal to our theta 80 over 360 multiplied by 2 multiplied by pi multiplied by 9. And yet again, this is one where when you plug it into your calculator, you got to make sure you're being careful. I need to take a drink and a pause. All right, I probably just hopped around the video or something on yours, but yeah, like I said, I had to pause it to get a drink of water. Anyways, so I'm going to turn this calculator on. Oh my gosh, the glare is terrible over there. Glare is much better over here, but now you can't see the page. Wonderful. All right, so we're going to go ahead and type this in, but we type it in the calculator. We're just going to skip the pi, or you can make the pi equal to a 1, whatever makes you happier. I'm just going to skip it when I type it in. So maybe you make a little note for yourself. Hey, on this guy, skip pi on calc. That'll remind you just to get rid of that thing on the calculator there. Anyways, let's just do it. So we're going to go alpha, y equals enter, or if you have the newer ones, like the newer calculators actually right here, there's a little green fraction bar. So you hit second x, but that's not on this calculator yet. You can see it's just not there. Anyways, 80 over 360. I could probably update the operating system to make it work, right? Skip the pi and then times 9. You can see it just gives us 4 right away. If you did feel like trying to do this question in your head, you could. The zeros would cancel out here. 2 times 9 is 18. 18 over 36 is half. And then finally, half of 8 is 4. Done. Easy peasy. We're going to go ahead and write our final answer there. 4, and it's length, right? So we're going to go ahead and answer with a single unit, feet. As our sector area here, we're going to go ahead and put that our sector area is in fact 80 over 360 multiplied by pi multiplied by that 9 squared. Yet again, could do the exact same thing. Kind of running out of room here. This is like not enough to write our whole answer here. Oh well. So same exact thing. Alpha y equals enter. I probably don't need to be typing this all in the calculator. I showed you once, but you know what? Let's maximize that laziness. We got 18, and I'm going to go feet squared. Easy enough. Moving on, here we go. They continue to give us the formulas. It's exactly the same formula. Don't know why they're asking the question again, but you know, here we go. We're gonna go S is equal to, and it actually doesn't label L. I actually didn't think about that because you could have been thinking about the outside edge, right, instead of the 120, but whatever. All right, 120 over 360 times 2 times pi times our radius of 3. What's that going to be? Well, the 120 over 360 is actually a third, so a third and 3 cancel out. We just get 2 pi feet. As the area is going to be the same exact concept, 120 over 360 times pi times our radius squared. Yet again, that's a third. 3 squared is 9. A third of 9 is 3. And we end up with 3 pi feet squared. Boom. Use our conversion factor. 180 over pi. What is the degree measure in radians? All we have to do is take that 4 pi over 15, and we are multiplying it by 180 degrees over pi. Typically, pi radian, you actually don't write the radian in a typical problem because radians are technically unitless. So you kind of look like a math newbie if you're writing the rads in there. So best not to do that. Pi's end up canceling out because they're on the top and the bottom. Feel free to cross yours out if you feel like it. 180 over 15 is 12, and 12 times 15 is in fact 48. And yet again, if you type that into your calculator, you pretend the pi's are a 1. You get like alpha y equals enter. You got 4. You got 15 times. We got again the pi is a 1, and you get that 48. Because the pi's are canceling there, or you don't need the pi's, right? You actually do need the pi's in the next question, though. All right, so same exact concept, but now it's upside down, and it gives it to us that it's upside down. How nice of them. I certainly wouldn't have done that. Multiplied by pi over 180. If you feel like putting it over 1 here, you can. Remember, when you put it into the calculator, you do not include the you do not include the pi. You write a 1 instead. So just going over here, same exact concept. Just to show you one more time. We get the 144 over 180. Actually, I should have just done it the right way I said it. 144 alpha 1 over 180. There you go. All right, cool. 4/5. Radians. And again, radians are unitless, so you just leave it. Boom. Number 18. This one is so fast, so simple. All we have to do is change the sign and take the square root. Change the sign, take the square root. Let's just write that down. Change the sign, take Square root. That's all you have to do on these questions. So this negative 10 becomes a positive 10. This is our center. And that positive 8 becomes a negative 8. And the radius is the square root of 49, which is just 7. That's the whole problem. How easy is that? And on this one, already had the square root. So this one is change the sign, square it. So change sign and square. Change sign and square. Okay, so what do we got? We got x minus 7. So again, that positive 7 becomes a negative 7 plus. And now, because there's a 0 here, what we're going to end up writing, so I'm gonna like go a different color for a second. You don't necessarily need to write this part, but this over here, I'm going to be doing y minus 0, right? But because it's minus 0, it's the same thing as it not even being there, you know, so I don't need all of those parentheses. So I'm just going to write our y squared, and then again, we're squaring that 25. Or that 5, sorry, not the 25. Okay. Given this one, radius r, what is this equation? So this one we got to look at the circle, and we got to figure out, hey, where is our radius and center here? So this one right here is going to be our radius. So our radius has a length of 2. And our center here, in my opinion, is nice and obvious at -1, positive 4. So just like number 19 there, change the sign and square. So we're going to go ahead and do +1 plus y minus 4. Squaring the 2 gives you 4. We done. Have a great rest of your day. Peace.